From knowledge bases, to ontologies. This is episode 2, What is an ontology? Last time we felt the problem in our bones, knowledge scattered everywhere, and machines that simply cannot understand it. We ended on a single word as the answer to all of it. Today we make that word precise. By the end of these few minutes, ontology will stop being a vague piece of jargon, and become 5 concrete building blocks that you could sketch on a whiteboard yourself. So let us pick up exactly where we left off. We said that an ontology is a shared, formal, machine-readable map of a domain's meaning. Now, that is a perfectly good slogan, but a slogan is not a definition. If somebody actually handed you the job of building one, what, concretely, would you write down? To answer that honestly, we start with the definition the entire field still quotes to this day, and then we take it apart, word by word, until there is nothing mysterious left in it. In 1993, a Stanford researcher named Tom Gruber gave the definition that stuck. An ontology is a formal, explicit specification of a shared conceptualization. For words there are doing all of the heavy lifting. Formal, meaning a machine can process it, not merely a human. Explicit, meaning everything is stated outright, with nothing left implied or assumed. Shared, meaning a whole community agrees on it, rather than it being one person's private notes. And conceptualization, meaning it captures the concepts of a domain, not just its raw data. Formal, explicit, shared, conceptualization. Hold tightly on to those 4 words. And here is the quiet power hiding in them. The moment all 4 are true at once, a domain stops being a loose pile of documents, and becomes something that a machine can genuinely compute over. If that definition still feels a little abstract, here is the plain language version that I like to use. An ontology is a precise map of a domain. Or, even simpler than that, it is a dictionary, plus a grammar, for a domain. The dictionary tells you which concepts exist and exactly what they mean. The grammar tells you how those concepts are allowed to combine, and what can simply never be true. Give a machine both that dictionary and that grammar, and for the very first time it can read a domain the way a trained human expert reads it. So what exactly goes into that dictionary and that grammar? An ontology is built from 5 kinds of building block. And here is the reassuring part. Every ontology you will ever meet, whether in medicine, in finance, or in manufacturing, is made of these very same 5. Concepts, the things that exist. Attributes, the features those things have. Relations, the ways they connect. Axioms, the rules they must always obey. And instances, the concrete individuals. Let us now walk through all 5, one at a time, using a single running example that we will keep all the way through, a university. Block 1, concepts, also called classes. These are the core nouns of the domain, the kinds of thing that exist in it. In our university, the concepts are things like student, teacher, course, and department. Notice that a concept is not any particular student. It is the category itself, the very idea of a student, the template that every real student will eventually fit into. Get the concepts right, and you have the skeleton of the entire ontology, because everything else we add from here will hang directly off them. A useful little test, when you are starting out, is simply to underline the nouns in the way an expert describes their world. Those nouns are very often your first concepts. Block 2, attributes, which are often called properties. These describe a concept, and they come in 2 distinct flavors that are well worth separating clearly in your mind. Data attributes hold a plain value, a student's name, their student number, their grade point average. Object attributes, by contrast, point from one concept across to another, a student enrolls in a course, a teacher teaches a course. So one kind of property carries a piece of data, and the other kind carries a connection. Both of them are how a bare, empty concept gains its real detail. Block 3, relations. If object attributes are the individual links, then relations are the overall structure that all those links create together. 2 patterns tend to dominate. The first is hierarchy, the is-a relation. A graduate student is a kind of student, which is in turn a kind of person. This is what lets a machine inherit knowledge downward, automatically. The second is association, ordinary links between peers. A teacher supervises a student, a course belongs to a department. Hierarchy stacks the concepts into a tree. Association wires them into a web. Together, those two give the domain its actual shape. Block 4, Axioms. And this is the block that truly separates a real ontology from a pretty diagram. Axioms are the eternal truths of the domain, the rules that must always hold, written down formally so that a machine can actually enforce them. In our university, one axiom might say that a student belongs to exactly one department. Another might say that every single course must have at least one teacher. These are not data. They are hard constraints on what the data is even allowed to be. And crucially, a reasoning engine can use them both to catch contradictions, and to discover brand new facts that you never stated outright. That second power is the surprising one. From just a handful of axioms, a reasoner can quietly deduce conclusions that were true all along, and yet were never written down by any human anywhere. Block 5, Instances, sometimes called individuals. If concepts are the blank templates, then instances are those templates filled in, the concrete individuals that genuinely exist in the world. The student Zhang San, with student number 2024001, studying artificial intelligence. The course, Introduction to AI, with the code CS101. Each instance is stamped with a concept, this thing is a student, that thing is a course, and it immediately inherits everything the ontology already says about that concept. Instances are the point where the abstract model finally touches the real world. Now watch all 5 of them snap together into one single picture. At the top sit the concepts, student, teacher, course, department. Below each one, its attributes hang off, a student has a name and a number. Then the relations wire everything up, a teacher teaches a course, a student enrolls in that course. The axioms float above it all as rules, one student, exactly one department. And at the very bottom, the instances land, Zhang San the student, Professor Li, the AI course. 5 layers, one coherent map. That, in a single diagram, is a complete ontology for a university. And notice something quietly powerful. Nothing here is special to universities. Swap those 4 concepts for patient, doctor, drug, and dose, and the very same 5 layers hand you a clinical ontology instead. There is one more distinction hiding in that picture, and it pays off so well in a later episode that I want to plant it right now. Notice that the top 4 blocks, the concepts, attributes, relations, and axioms, all describe the structure of the domain, its schema. The 5th block, the instances, is the actual data sitting inside that structure. Knowledge engineers give these 2 halves names. The schema half is called the TBox. The data half is called the ABox. Just keep that split quietly in the back of your mind, because in episode 4 it turns into a beautifully clean equation. You might fairly ask, why go to all of this trouble, when a database was so much easier to build? Because writing the meaning down explicitly buys you 5 things that a database never could. Semantic interoperability, where 2 different systems finally agree on what a word actually means. Reuse, where you build the map once and many systems quietly share it. Reasoning, where the machine derives facts you never once typed in. Explainability, where every single conclusion arrives with an auditable chain behind it. And extensibility, where you grow the model without ever tearing down what you already had. 5 concrete payoffs, all of them flowing from those same 5 building blocks. And these are not abstract niceties. Each one maps to real money saved, in integration projects that no longer quietly stall, and in compliance audits that finally pass on the very first attempt. So that is an ontology, finally stripped of all its mystery. A formal, explicit, shared conceptualization, built from 5 blocks, concepts, attributes, relations, axioms, and instances, and split cleanly into a schema and its data. You could genuinely sketch one yourself now. Next time, we ask where on earth this idea actually came from. Episode 3, 40 Years of Evolution, Tracing the Path from Ancient Greek Philosophy all the way to Modern AI Infrastructure. See you there.